Hello students, today we'll be learning geometry, that is mathematics part 2. Like previous year, this year again you have two books, that is algebra and geometry. So when I'm talking about geometry, you will be having 40 marks paper. Here there are 7 chapters which you will be studying this year. So let me give you a brief idea related to these chapters. First three chapters, that is similarity, Pythagoras theorem, circle, all are theorem based chapters. Geometric construction is a construction based chapter. Coordinate geometry, trigonometry, mensuration are formula based chapters. Today we'll be starting with first chapter, that is similarity. Students, you must have played with this type of doll in your childhood. If you open this doll, you will find another doll. Again opening, you will find another one, and so on. You will see that all these dolls look exactly similar with each other. The only difference is their size. In geometry, we use the term similar to indicate same shape and different in size. If we go to photographer with the same negative, he can give us two photographs of any size. Here, photo is exactly the same, but the size are different. We call them as similar. In earlier standard, we have studied about congruent images. You can see here, we use symbol to represent congruency. These two lines of the bottom shows the same size and the inverted S shows the same shape. Look at this picture. These are similar. Here they are same shape but not necessary of same size. A same shape is indicated by inverted S we use to represent similarity. Hence these two images are same in shape and different in size, hence they are called as similar. Now we will try to apply this in geometry. Look at this figure one by one. We'll see first one, line segment. They are same shape but size are different, hence they are similar. Again this squares, different size but all are similar figures. Same with the circle. When we talk about same shape, circular but are of different size. When can I say that these are similar? If they have same shapes. They doesn't seem like similar in shape, hence these two are not similar. Now look at these triangles. One small and another is larger but with same shape. Now put them like this. You can see one is inside and other one is out. Right? Are they similar? If we take one more triangle, a bigger triangle, what will happen? Are they similar? One inside the other. This way you can put. Hence, the outermost triangle looks like a projection of innermost triangle. If we call this as 1, 2 and 3. So I can say 1 is similar to 2, 2 is similar to 3. So 1 is also similar to 3. You can see. Place lighter bulb at point O on the ceiling and directly below it on a table. Place XYZ to the ground between the lighter bulb and the table, such a way its shadow must cast on the table. So first triangle will name it as XYZ and another triangle form will name it A, B and C. Or you can see over here ABC is a larger triangle as compared to XYZ. Yes, we can see the vertex X is correspond to A, B is correspond to Y and C is correspond to Z. We can say triangle ABC is similar to triangle XYZ. To find this property, let me measure the angles. So when we measure the angles with the help of protractor, A will get 60, B will get 60, C you will get 60. Same when I talk about X 60, Y 60 and Z 60. So when I am talking about this, angles of these two triangles are similar. Now let me can see angle A is equal to angle X, B is equal to Y and C is equal to Z. This means corresponding angle of these two triangles are similar. Now we'll measure the sides. All three sides will get 4 of triangle ABC and all three sides of triangle XYZ you will get 2. Can you see it's nothing but it's in proportion? That is, I can see XY to the side of another triangle, right? XY is 2, where it is AB is the double of it, it is 4. So I will say AB is equal. So yes, AC is twice of 2 into twice of 2x. BC, when I am talking about, it will be twice of YZ. Now let me write this in a ratio form, that is AB upon XY, that is equal to 2, AC upon XZ equal to 2, BC upon YZ is equal to 2. I can say all my right hand side are equal to 2. It means my left hand side will be also equal. So I can say AB upon XY is equal to AC upon XZ is equal to BC upon YZ. Right? It means the ratio of corresponding sides of two triangles are same. The ratio is same. Right? Two similar triangles. All congruent triangles are similar, but converse is not true. Now let me first see how to find the ratio of area of two triangles. Now when I'm talking about two triangles, but obvious it will be 2. Now when I'm talking about area of two triangles, let me see the question. Ratio. Ratio means it will be numerator and denominator. So it will be in numerator form and denominator form. That is area of first triangle upon area of second. Area it means we have a formula of area of triangle is half into base into height, right? And two triangles, that is we are taking in the form of ratio, that is area of first triangle and then another second one. So let me see how we get the answer. Ratio of area of two triangles. Let me see the sum. When I'm talking about this, let us find the ratio of area of two triangles. Here there are two triangles, triangle ABC and triangle PQR. So when I'm talking about this two triangle, AD is the height of first and BC is the base. Then I'm talking about the another, PS is the height and QR is the base. So area of first triangle upon second triangle is equal to half into base into height. That is BC into AD upon half into QR into PS. Half and half are similar, right? So next line will be area of triangle ABC upon area of triangle PQR equal to half and half get cancelled. BC into AD upon QR into PS. This is an important line, students. You have to write these lines in your notebook. Right, ratio of the products of their bases and corresponding heights. Now let first triangle BC will be the B1 and height be H1. QR be B2 and PS be H2. So then the ratio of this area I can say B1 into H1 upon B2 into H2, right? Let me take the another condition imposed on two triangles. So first condition, when the height of both triangles are equal, then what we will do? So let me first take area of a triangle ABC and area of triangle PQR. When I am taking area of triangle base into height, BC into height, QR into height. Height and height are common, so it will be cancelled. So left is BC upon QR. Therefore, area of triangle ABC upon area of triangle PQR is equal to BC upon QR. It is B1 upon B2. Write this property. The ratio of the area of two triangles with equal height is equal to the ratio of their corresponding base. You have to write this with the diagram. Second condition, when the bases are common. Triangle ABC upon triangle APB. When I am talking about bases are same, it is AB into H1, AB into H2. AB and AB will be cancelled. So left is H1 upon H2. You have to draw this diagram as well as this sum with the property given here. The ratio of the area of two triangles with equal base is equal to the ratio of their corresponding height. Students, here you have to write this all conditions. We will be checking the sums whether you have done or not with a neat and clean diagram. When I'm talking about property given in a box, it's very important. Why? We will write this property when and where required in the answer. You remember we always write the brackets, right? So this all properties will be writing in a bracket form. So you have to thorough with the given properties. So let me start. Now I hope you have understood what we have learned till yet. There is area, height and base. When triangles with the equal base, a triangle has an equal height. So now let me see the activities. Are you able to do it or not? So let me check. First activity. It's like fill in the blanks. Triangle ABC and area of triangle APQ. So when I'm talking about this triangle, we will write area of triangle ABC is equal to base into height, and area of triangle APQ equal to base into height. Height is common, so AR will be cancelled. So final answer is BC upon PQ. Highlight the answer like this, and final statement you have to write. I told you before, you have to write. It's compulsory. Let me go to the next one. Second, area of triangle LMN and area of triangle DMN. See to it that you are writing it properly. What is the base and what is the height? So base into height when I am talking about LMN as the base MN and height LP, and again DMN has base MN and height DQ. When I am talking about this, MN cancel, LP upon DQ is the final answer. Highlight your answer this way and write the property. Let me move to the third one. You have to write all this activity in your notebook. This is the third activity. You have to take your book and pen. You have to draw the diagram like a fill in the blanks. You have to write the questions, and you have to do this activity by your own. First understand, try to solve your activity by your own. I am giving you the answers also, but try that you pause the answer. Wherever there is a question, pause it. Solve your activity by your own. I am repeating it. Solve it by your own. So let me go to the third one. Here, third question, we are given the state the reason. So when I am talking about reason, you have to write the reason. You have to be very particular about the reason. So I am talking about area of triangle AMC and BMC. Base into height. Here you can see CM is the median. There is no height. So we have to do the construction of CM to the base AB, and we have to give a height. So here we can see H is the common height of both the triangle. So now, because of the median, AM is equal to MB, hence bases of both the triangles are equal as it is a median. So ratio of area of two triangles is equal to the ratio of product of their base and corresponding height. So here when I am talking about area of triangle AMC and BMC, it will be equal to AM into height, BM into height. Height and height is equal, that is AM upon BM. Again AM and BM with a better option. So let me start with the solve sums. In the adjoining figure, AE is perpendicular to segment BC, segment DF is perpendicular to BC, A is 4, DF is 6. Find area of triangle. So you can see here the value is given of both the heights of a triangle. So let me start with the area of triangle ABC and area of triangle DBC. So base into height, that is ABC BC upon So let me start with the solve sums after the activity based questions. In the adjoining figure, A is perpendicular to segment BC, DF is perpendicular to line BC, AE is equal to 4, DF is equal to 6. Find the area of triangle ABC and area of triangle DBC. So let me start with the answer. You can see here AE is given a value and DF, which is the height, both have been given the value. And in both the triangle you can see the common base. So area of triangle ABC and in area of triangle DBC, I mean say base are equal, I'll say AE upon DF, that is the height. Bases are equal, hence their areas proportionate to height. This statement is important. So 4 upon 6, that you have to write it in 2 upon 3 form, that is again so here bases are equal, hence area proportionate to height. So here 4 upon 6 can be reduced as 2 upon 3. You have to highlight your answers like this. In triangle ABC, D on the side BC in such a way that DC is 6, BC is 15. Find area of triangle ABD and area of triangle ABC. Two ratios are given here when I am talking about this triangle. BC full is given as 15, where DC is given as 6, right? And area of triangle ABD is asked and ADC is also been asked. So let me start. A is the common point, common vertex of all the triangles. Their bases are therefore collinear. So when I am talking about the collinear, they all lies in a straight line. So here when I am talking about this, you have to write the given part here. When I am talking about whole BC, DC is 6. So what will be your BD? So So we'll say BD is nothing but whole BC minus 6, that is 15 minus 6, that comes 9. So area of triangle ABD and area of triangle ABC is equal to BD upon BC. Equal heights, hence area proportionate to its base. Again, area of triangle ABD can be written as number 9 upon 15, that comes to 3 upon 5. Area of triangle ABD and area of triangle ADC, so I will say BD upon DC. Heights are equal, hence area proportionate to bases. Therefore 9 upon 6 can be reduced in a form as 3 upon 2. Highlight your answers like this. Let me start with the third one. Parallelogram is given to you. Is any point on side BC. Find two pairs of triangle with equal areas. So let me start with the answer. When I am talking about this parallelogram, ABCD is a parallelogram. AD is parallel to BC and AB is parallel to DC. Right? Consider triangle ABC and consider triangle BDC. Both the triangles are drawn in two parallel lines. Hence, the distance between the two parallel lines is the height of both triangles. In triangle ABC and in triangle BDC, common base is BC and heights are equal. So here area of triangle ABC is equal to area of triangle BDC. Hence, triangle both have a common base and height are equal. Therefore, I can say hence area of triangle ABC is equal to area of triangle ABD. So you can see here as the triangles are proportionate to their base, right? So now let me take how to find AC. AC is given as 16. DC is 9. AD is equal to 16 minus 9 equal to 7. So here area of triangle ABD upon ABC is equal to AD upon BAC. We are not considering the height as the heights are equal. You have to write the values as it is. If it is getting cancelled, then cancel it, not keep it as it is. Write the brackets. Area of triangle, area of triangle. So let me start with area of triangle BDC and ABC. DC upon AC, write the values given to you have been find, that is 9 upon AC, that is 16. Keep it as it is, write the bracket. Third one, ABD and area of triangle BDC, that is AD upon DC equal to AD value is 7 and DC is 9. So 7 upon 9 is your final answer. So So students, let me sum up what we have learned till yet. Area of a triangle, half into base into height formula. Area of, that is ratio of area of two similar triangles, that is A1 upon A2 is equal to B1 into H1, B2 into H2. Again, when we talk about the ratio, we have three cases with us. First case, when it has a common base. So when it has a common base, we'll write as A1 upon A2 is equal to H1 upon H2 bracket, since it has a common base. Triangle having equal height, that is A1 upon A2 is equal to B1 upon B2, since it has a common height. And third, that triangle having equal height and common base, we'll write A1 is equal to A2, since equal height and base. Students, you have to solve some assignment questions also. So there are some assignment questions for you to do as a homework. So first one you can see on the screen. You have to pause this time and you have to write these questions. So here you can see BE is perpendicular to AB, segment BA is perpendicular to segment AD, BE is 6 and AD is 9. You have to find the area of both the triangles. I'll just give you a hint how to solve. When you have two triangles and when you have a common base, you'll be using the property of common base. So it's a very simple one. Second one. In the figure, SP is the height of a bigger triangle and YT is the height of smaller triangle. Now I gave you a hint how to solve this sum. You have to find the values of both the areas of a triangle. You have to find the values. Don't write the variables and k. Final answer must be in the form of values. Third one, ratio is given to you, RP and PK. Then find the value of the following ratio. When nothing is given, take the common multiple as any variable, say x, k or anything, and solve the sum as per the base and the height. Again, we will be writing the final answer in the form of values. You can write the questions, you can take your own time. You can see the last sum over here, given over here. You can see three heights, right? PR, AX and QT. So when I'm talking about three heights, different triangles have been asked to you, no values are given to you, it means you have to write in the answers in the form of B1 into H1 upon B2 into H2. So complete your answers. I hope you will be able to solve these sums very easily. If you are not, go through with this video so that the ideas are clear and you are able to solve the sums. Thank you, students.